Today we'll discuss the numericals on Laplace transformation and application of Laplace transformation on electrical circuits. Let's see first example, that is find the Laplace transformation of f of t for the shown below. For this we have to find out what is the f of t. To get that f of t, what we have to do here is we require this signal. So to get such signals, what we can do is we know the sinusoidal waveform, which is of a sine pi t, okay, and we know unit step function, that is u of t, okay. So this is from 0 to t and this is also from 0 to t. So we know u of t and we know sine omega t. Now by taking these two into consideration, we can make or we can get a signal like this. To get that signal, what we can do is, for this particular signal, by taking this particular signal, if we are multiplying, to get that particular signal, we can multiply the sinusoidal wave into a signal like this with a pulse, which is of a range from 0 to 1 with a magnitude 1. If you are multiplying this signal with this sinusoidal signal, then we get it should be of 0 to 1, okay, with the sine pi t it is, and it is u of, will calculate what is this, okay. So if you multiply this signal and this signal, so we get a required signal, that is this one. To get, so we'll multiply this sine omega t signal into this signal. So task is to calculate this signal. How we can get this? We can get it by two unit step signals, that is, first one is from 0 to t with a magnitude t has to be subtracted from another signal which is starting from 1, okay, 0 to 1. So this signal is called as u of t, and this signal is which is starting from 1, which has a delay, it is called as u of t plus 1, sorry, should be t minus 1, okay. One signal is this 0 to t with a magnitude t, which is u of t, and another signal should be starting from u of t minus 1, which is of delay of 1 second. If you minus this first signal minus this u of t minus 1, u of t minus u of t minus 1, you get a signal like this. That is a required signal, okay. So once you have got this signal, which you can multiply with sine pi t signal. So let's take x1 is the sine pi t signal and x2 is this pulse, which is of magnitude is 1 and its range is, or duration is 0 to 1. So you multiply these two. So for that, get a first that is f of t. To get that, x1 of t into x2 of t, where x1 of t is this signal sine pi t and x2 signal is, you can write x2 of t will be equal to u of t minus u of t minus 1 signal. So multiply those two. Here this is x1 and this is your x2 signal. So now we can multiply these two, that is x1 into x2, which gives us sine pi t into u of t minus u of t minus 1. So multiply these two. First factor will be sine pi t into u of t minus the second factor is sine pi t into u of t minus 1. Now what we have to do is take a Laplace transformation of this f of t, which is equal to Laplace transformation of this minus Laplace transformation of this, okay. Now to get easy thing is Laplace transformation of sine pi t u of t is nothing but your Laplace transformation of sine pi t only, okay. We know this. So easily what we can do is, you can till the end we can keep as it is this term. But second term, if you are observing, Laplace transformation of second term is Sin pi t, u of, it is u of t minus 1. Here delay is minus 1 and here it is sin pi t. So which is not matching. So what we have to do is mix a little alter, that is sin pi. Instead of writing t, you can write t minus 1 plus 1. So mathematically it is true. Okay, get cancelled. So it is take t minus 1 plus 1. So this as it is. Okay, sin of t minus 1 plus 1, u of t minus 1. So now what we can do is sin a plus b, where a is t minus 1, where a is t minus 1 and b is 1. Okay, now you can apply sin a plus b formula, that is sin a cos b minus cos a sin b. Apply sin a is t minus 1, sin a cos b, b is, here what we are taking is 1. Okay, cos of 1 into, here we have a pi, therefore it should be cos pi. Okay, here also it is sin a means sine of pi into a. Okay, this is a plus b, so it is pi a plus pi b. A is t minus 1, so it is a of t minus 1 is, pi of a t minus 1 is your a. Okay, b is b equal to pi. Okay, that you have to substitute. Here sin a cos b, okay, cos of b, which is pi into 1, which is cos pi, minus sin b cos a. Here it should be cos of pi t minus 1. Therefore in this signal sin pi is 0, so this total term will be 0. Okay, and then same this you can keep as it is, and Laplace transformation of, you can get only first term, that is sin pi of t minus 1 into cos pi, okay, into u of t minus 1, where cos pi meaning is minus 1. You can substitute it. Okay, so further you can simplify it. Laplace transformation of, okay, this minus sign we can bring here, which gives us a positive. First term as it is we have kept. Laplace transformation of sin pi t u of t plus L of sin pi t minus 1, which is sin a was there, and u of t minus 1. Now apply Laplace transformation of this. Laplace transformation of sin pi t is pi by s square plus pi square. Okay, plus e raised to, this is again second term, Laplace transformation of this term will be again pi by s square plus pi square, but there is a delay of minus 1. Therefore wherever there is a delay, you have to just multiply with e raised to minus 1s. If you have delay of 2, then it would be e raised to minus 2s into pi divided by s square plus pi square. If it would have minus 3, then it will be minus 3s. Okay, so only delay we have to consider here, and then Laplace transformation of pi only, sin pi we have to write, which is pi divided by s square plus pi square. So we'll consider another numerical. Read properly. A rectangular voltage pulse. A rectangular voltage pulse. Okay, there is a rectangular voltage pulse of a unit height, means its height is unit. Okay, unit height, and duration is t. Okay, duration is t. Then it means it is from 0 to t. This signal is rectangular pulse, voltage pulse of a unit height and duration is t, is applied to a series RC combination at t equal to 0. Determine the voltage across the capacitance C as a function of time. Use the Laplace transformation method. What we have to do is, so suppose if we have for series RC circuit, this is R and C, which is both are in series, R and C. Okay, and this is the voltage. Here for this we have to find out I of t. First we'll find out I of t when we have only V. Okay, and then again suppose if the voltage is changed according to this, we'll consider. Okay, now so consider consider R C with the voltage source V only. We are not considering this example now. A simple example which is of this. So we have to calculate I of t. Now to calculate this, what we have to do is apply KVL for this circuit. What we have to do is apply KVL for this circuit, which is equal to apply KVL R into I of t plus voltage across capacitor, which is 1 over C integration of I into dt, okay, equal to V of t, which is we have applied KVL for this. Okay, now we have to take a Laplace transformation of this given signal. So this what is a Laplace transformation of R is remains same, elements are remains the same. I of t's Laplace transformation is capital I of s. Okay, next 1 over C as it is. Laplace transformation of integration is 1 by s. Okay, integration, Laplace transformation of integration is 1 by s, and I of dt's Laplace transformation is I of s equal to V of s, which is V of s. Now, so if you write systematically, then Laplace transformation of series RC circuit will be, which was R into I of s plus I of s divided by s into 1 over C, which is equal to V of s. Therefore, I of s you can take outside from these two. Then there will be R plus 1 over SC or CS equal to V of s. I of s will be equal to V of s divided by whatever the term is there, R plus 1 over CS. This is Laplace transformation of RC circuit, simple RC circuit. Now, in this case, voltage is not V of s, voltage is this rectangular voltage pulse. So first we have to calculate what is this V of s, then we can substitute in this. Now we'll have that first rectangular voltage pulse from 0 to t. Let's find out first its Laplace transformation, and then we can apply this as a voltage to this RC circuit. Okay, so to calculate this easily we can write that we have a two-step unit step functions, that is one is u of t, and if you minus this with another unit step which is of a delayed signal from t, that is u of t minus capital T signal. If you minus this with this, then we get a particular signal. Therefore, this V of s will be now equal to u of t minus u of t minus capital T. Okay, we can find out, sorry, this is V of t, time signal. So now we can apply Laplace transformation of this, then it will be u of t's Laplace transformation is 1 by s, and u of t minus t's Laplace transformation is again u of t, so therefore it is 1 by s. Since it has a delay of minus t, then it has to be multiplied with the minus ts. That's it. Okay, this voltage we have to take, and then we have to apply for this particular series circuit, RC series circuit. Let's see. We have a RC series circuit. Instead of a voltage, we have this signal, and we have this V of t, u of t minus capital T. And remember one thing, Laplace transformation of differentiation is s into x of s, and integration is 1 by s. So we'll find out, first apply as usual. Now we know the V, right? We can apply here, only we can write the KVL for this particular circuit is R into I of t plus 1 over C into integration of I of t into dt equal to V of t. Okay, now we'll apply Laplace transformation for this. Once we have applied C, we have got this, and then V is u of t minus t. Okay, in the same equation, And now apply Laplace transformation directly, that is r into I of s, okay, plus 1 over c. Integration's Laplace transformation is 1 over s into I of s equal to u of t is 1 by s minus this is 1 by s into e raised to minus ts. So this is a simplification, that is I of s you can take outside from this, or earlier what we have done directly you can substitute in that formula also. Okay, I of s is equal to I of s, if you take a common term then r will be inside and plus 1 over cs will be there, which is equal to 1 by s you take a common term, then 1 minus e raised to minus t of s will be there. Therefore I of s will be 1 over s into this numerator divided by this is the denominator, that is r plus c s. Then so now we have got I of s, but they have not asked you to calculate the current. They have asked us to calculate, see, determine the voltage across the capacitor. They have asked us to calculate the capacitor. Okay, now we know this current. Now we'll apply voltage across that capacitor. Voltage across capacitor is 1 over c integration of I of t into dt. So let's take its Laplace transformation. Then it will be 1 over cs into I of s. Whatever I of s we have, this you have to substitute here. That's it. Vc of s. This is Vc of t. This is Vc of s after taking Laplace transformation, equal to 1 over cs into I of s. Same thing. That is 1 by s, 1 minus e raised to minus ts divided by r plus cs. Further simplify. Now we'll take a Laplace transformation of a simplified equation. Sorry, here it should be minus 4u of t minus 5. Let's take a Laplace transformation of this. In this entire equation, all are of u of t. Okay, only with a delay t minus 1, with a magnitude 1 u of t minus 1, with a delay t minus 2, with a delay t minus 3, with a delay t minus 4, and with a delay t minus 4, t minus 5, and minus 4 is the magnitude. As we know, the Laplace transformation of u of t is 1 by s. So all are of u of t is only with respect to delay we have. So all of other parameters are of 1 by s, because u of t's Laplace transformation is 1 by s. So first factor is u of t minus 1. So 1 by s u of t's Laplace transformation is 1 by s, and t minus 1 is the delay. Therefore it should be e raised to minus 1s, plus second factor is also u of t. Therefore its Laplace transformation is 1 by s, into delay is minus 2 seconds. Therefore it should be e raised to minus 2s. Similarly 1 by s into e raised to minus 3s, and u of t minus 4. Therefore it should be 1 by s into e raised to minus 4s. Minus 4 is the magnitude into 1 by s, because it is again a u of t minus 5 is Laplace transformation. So 1 by s into e raised to minus 5s. So minus 4 is the magnitude. It has to be kept as it is. Now in the above equation, 1 by s is the common factor. You can take outside. Then remains inside is e raised to minus s. All magnitude and time delays will be inside. That is e raised to minus 1s, minus 2s, minus 3s, minus 4s, minus 4 into e raised to minus 5s. Now this is our voltage in the form of v of s. This is the Laplace transformation of staircase. Now we have got a v of s. We have to apply this one to the RL series circuit, where we have this circuit. Directly we can write the equation what is I of s of this circuit, but now we'll discuss in detail what is the Laplace transformation of this RL circuit, series circuit. So apply KVL for this loop. When we apply KVL for this circuit, we get R into I, okay, R into I, then L into voltage across this, so L into di by dt, then equal to v of t. Let's take a Laplace transformation. As we know, Laplace transformation of differentiation is s into the function, and Laplace transformation of integration is 1 by s. Therefore, let's take a Laplace transformation. As we have discussed, elements will be remains the same. So now r into I of s, L remains the same. Differentiation, Laplace transformation of differentiation is s into that function which is I of s, which is equal to v of s. Laplace transformation of v of t is v of s. Then substitute r equal to 1 and L equal to 1, their values 1 ohm and 1 Henry. Once you have substituted in this equation these values, then we get I of s, okay, plus s into I of s equal to v of s. So simplify, I of s you can take outside, there will be 1 plus s equal to v of s. Therefore I of s will be equal to v of s divided by 1 plus s. This is our I of s equation. Now in this equation we have to substitute what is the value of v of s, which we have calculated earlier from the staircase waveform. So just we can substitute this I of s equal to v of s divided by s plus 1 or 1 plus s. In that formula, denominator remains the same, which we had a formula was v of s, I of s is equal to v of s divided by 1 plus s. So this remains same, only v of s value we have substituted from a staircase which we have calculated. So observe in the next step what we can do is, we can numerator as it is, but the denominator can be written as s into 1 plus s. So this s denominator is common for all the factors. Therefore we can expand it like e raised to minus s divided by s into 1 plus s plus e raised to minus 2s divided by s into s plus 1 plus s, and so on. Now this factor can be written as 1 divided by s minus 1 divided by s plus 1 into e raised to minus s. Similarly, this can be written, all factors are of same. Okay, can be written minus 4 is the magnitude, it has to be written as it is. Now this has e raised to minus s, okay, it is minus 2s, minus 3s, minus 4s and minus 5s. Now we'll take one factor's inverse Laplace transformation because it is I of s. Task is to find out I of t. Okay, so we have to apply inverse Laplace transformation for this. To calculate that, I'll consider only one factor and remaining factor all are of same. If you are observing, all factors are of same, only thing is delay is different for each factors. Let's see, let's take a 1, that is 1 by s minus 1 by s plus 1 of e raised to minus s. Inverse Laplace transformation is, before finding out Laplace transformation of u of t, we know that is 1 by s. Then 1 by s's inverse Laplace transformation should be u of t. Then we have that 1 by s, then its inverse Laplace transformation will be u of t minus. As we know, Laplace transformation of e raised to minus t, okay, e raised to minus t into u of t's Laplace transformation will be 1 divided by 1 plus s. Similarly, inverse Laplace transformation of this one will be e raised to minus t into u of t. Here we have that, so it should be u of t minus e raised to minus t into u of t. Then what about this delay? What do you mean by e raised to minus s? Laplace transformation of t minus 1 delay is nothing but e raised to minus s. Therefore t should be equal to t minus 1. Similarly, if this is of 2s, then it should be remain same, u of t minus e raised to minus t into u of t, where t is t minus 2. Suppose if it is of 3s, e raised to minus 3s, then this remains the same, u of t minus e raised to minus t u of t, where t is t minus 3. If it is 4, then it is 4, 5, it is 5. So these factors remains same. Observe, all factors are remain same, only delay for first one is t minus 1, t minus 2, t minus 3, t minus 4 and t minus 5. Now what we can do simplification is u of t we can take outside from each term, that is 1 minus e raised to minus t u of t, okay, where t has to be substituted as t minus 1. Similarly, second factor, here also we can take u of t outside, that remains 1 minus e raised to minus t u of t, only thing is t has to be t minus 2. Similarly, we can write all the other terms, and then now next term we can substitute wherever t we have, in the place of t we have to substitute t minus 1. Here we have a t and u of t, okay. So there, if you are substituted these values, u of t is nothing but t minus 1, u of t is t minus 1, here t minus 2, t minus 2, t minus 3, t minus 3, t minus 4, t minus 4, and so on. So this is our required current of RL series circuit, where the voltage supply is of staircase.